Today we're going to be talking about similarity postulates and theorems. Our objective is that we will be able to identify and use similar triangles, and that we will be able to use similarity theorems to prove triangles are similar. So recall that similar triangles have congruent angles and proportional sides. So we have three similarity postulates and theorems that we can use to prove triangles congruent. The first one is angle-angle. So that would mean angle A is congruent to angle D, and angle B would have to be congruent to angle E. Or you could use C and F. As long as you have two pairs of congruent angles, this theorem will work. In the side-side-side similarity theorem, all the ratios of the sides have to be equal. So AB over DE would have to equal BC over EF, and CA over FD would have to be equal as well. For side angle side, the angle in between two of the proportional sides has to be congruent. So if AB over DE is equal to BC over EF, the angles in the middle, B and E, would have to be congruent. If you're using AB and AC, then A and D would have to be congruent. So let's look at some examples. Are these two triangles similar, and if so, state by which theorem? Well, here we need to use some of our prior information because we only know about one pair of angles. Well, we know that this angle and this angle are congruent because they are vertical angles, and those are always congruent. So yes, these triangles are similar by the AA postulate, or AA similarity. Here, since all the sides in this triangle are congruent to each other, and all the sides in this triangle are congruent to each other, we know the ratios will be the same. So yes, by side, 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 similarity. And the reason we have to write similarity at the end of these is because we also had our congruence postulates. Determine whether the two triangles are similar, and if so, state by which postulate. If they are similar, write a similarity statement, and then find the scale factor where possible. So here, we know that X and angle L are congruent. We don't know anything about the sides, so in order to prove that these triangles are similar, we're going to need to know the other angles. Well, let's look here. 180 minus 85 minus 45, because all the angles of a triangle add up to 180. That leaves us with 50 degrees. So K is 50. So now we know that K and C are congruent. So yes, they're similar by AA similarity. And now let's write our similarity statement. Triangle XYZ is similar to triangle. Now we need to match up the angles. X was 85, so L would be first. Y, we didn't know from here, but it must be 45, so it's the same as J. And Z was 50, and K is 50. What about this one? It looks like there's only one triangle, but there's actually two triangles. There's triangle CDG, this little one down here, that's stuck inside the bigger triangle of CEF. And you guys are seeing now why I'm not an art teacher. Since they overlapped at angle C, we know that angle C for both triangles are congruent. Now let's figure out the lengths of these sides. CD was 15, CG was 20, C to E was 15 plus 12, so this side's 27. And C to F would be 20 plus 16, which is 36. So we need to check and see if the sides are proportional. So 15 over 27 simplifies to 5 over 9. So now we need to check and see if 20 over 36 simplifies to the same amount, which it does. That's also our scale factor. So since the sides are proportional and we know the angle in between them is congruent, it's side angle, side similarity. And we can write our similarity statement. Triangle CDG is similar to triangle CEF. Now finally, checking to see which of these two triangles are similar. So we need to check each pair. So ABC and DEF. We have to do the small, the medium, and the large proportions. So the smallest side here is 16 over the smallest side here is 12. 16 over 12 simplifies to 4/3. The medium side is 20 over 16. 20 over 16 simplifies to 5 over 4. Well, those aren't congruent, so we don't even need to check the large sides. So that's not the pair. So let's try DEF to GHJ. Small, medium, and large. Smallest side is 12 over the largest side, which is 20. 12 over 20 simplifies to 3 over 5. Medium would be 16 over 25, which doesn't simplify, so it's just 16 over 25. So that pair doesn't work because those aren't congruent. So let's try ABC and GHJ. Small, medium, and large. Smallest sides would be 16 over 20, which simplifies to 4 over 5. Our medium sides would be 20 over 25, which would be 4 over 5. And our largest sides would be 24 over 30, which also simplifies to 4 over 5. So we know that triangle ABC is similar to triangle GHJ with a scale factor of 4/5. So before we get into the proofs, here's a few things that you might want to remember from previous units. Vertical angles. If we have two lines that cross like this, the angles across from them, those are vertical angles, and vertical angles are congruent. Alternate interior angles. If this line is parallel to this line, and we have a line going to both of them, so let me draw that a little bit better, then alternate interior angles are congruent. If we have two lines that are parallel, and then we have a line that goes by them, the corresponding angles are congruent. Reflexive angles you might not have seen as much when we were doing proofs the first time. Let's say we have a triangle like this, and inside of it we have a triangle like this. So let's say this is A, B, C, and this is D and E. If we separate them into the small triangle of B, D, B, E, and the larger triangle of A, B, C, Since these B angles were overlapping, we would know that those two angles are congruent because they're reflexive angles or because of the reflexive property. And the last reminder, when you see an S in SAS or SSS, it means the sides are proportional, not congruent, which means the ratio must be the same between each corresponding pair of sides. So our first proof, given this ratio, or this proportion, we want to prove that these two triangles are similar. So remember, we always start with our given statements. And our reason being that they were given. Well, since we know that all three pairs of sides are congruent, that means that we have side, side, side similarity. And so therefore we know that triangle TOP is similar to triangle LMN because we had all three sets of sides there. Given that AS over AC equals AR over AZ, prove that triangle CAZ is similar to triangle SAR. So again, start with your given. Then that's only two sides proportional. And the only one of our theorems that has two sides proportional is side angle side. So we need an angle in between these. So we have AS and AC and AR and AZ. And if you notice, they all have an A in the middle. So we must know something about this angle and this angle. Well, why would we know that those are congruent? Those are vertical angles. So now we can say that angle ZAC is congruent to angle RAS because vertical angles are congruent. Now we have side angle side. And that's how we know that triangle CAZ is congruent to triangle SAR. Given that GH is parallel to MN, prove that triangle GKH is similar to triangle NKM. Now actually there are a few different ways, probably 2 or 3 different combinations that you could actually prove that these two triangles are similar. I'm just going to show you one of them. So again, always start with our given statement. So we know that this side is parallel to this side. And those two sides are connected by this transversal. So we could say that this angle and this angle are congruent because they're alternate interior angles. So angle GHK is congruent to angle NMK because alternate interior angles are congruent. Well, because they also have the two parallel lines being connected by this line, we know that these two alternate interior angles are also congruent. So angle HGK is congruent to angle MNK by the same reason. Alternate interior angles are congruent. Well, we have two sets of angles, which means that we know that triangle GKH is similar to triangle NKM because of angle-angle similarity. And if we wanted to, we could have used the vertical angles instead of using both alternate interior angles and still proved it by angle-angle. And our final proof. Given BD is parallel to CE, prove that triangle ABD is similar to triangle ACE. So start with our given statement. So BD is parallel to CE. Because of that, we know that angle B and angle C are congruent because they're corresponding angles. So angle ABD is congruent to angle ACE because corresponding angles are congruent. Because the triangles overlap, we know that angle A is congruent in both triangles, so angle BAD is congruent to angle CAE because of the reflexive property. So then we know triangle ABD is congruent, not congruent, not congruent, similar to triangle ACE because of angle-angle similarity. That's all for today. Fill in your summary and I'll